we'd like to use the intermediate value theorem to show that there is a root for this function on the given interval. In order to do so, some conditions must be met. First, is the function continuous? Yes, it is. There's no domain restriction. So we do have continuity. Next, let's check out f of 4 and f of 7. For f of 4, we plug in. That's 16, take away 16, take away 6. We've got negative 6, good to know. Let's check out f of 7. When we do, 7 squared minus 4 times 7, take away 6. It's 49, take away 28, take away 6. The difference is 15. Okay, well, what we can take from that is that those function values, yes, they are different. F of 4 is not the same as f of 7. Furthermore, they have opposite signs. So we know that we've got a function value below the x-axis, a function value above the x-axis. It's continuous. So at some point we are touching the x-axis and there must be a root. When we evaluated f of 4, we got negative 6. We evaluated f of 7, we got 15. We could enjoy a lazy graph drawn by me, not very good. So 4 meets negative 6 somewhere down here. 7 meets positive 15 somewhere up there. This would be continuous. I'm not doing a good job here. But yes, there really would be a root. There would be a root somewhere around here, somewhere between x values of 4 and 7. So let's check these conditions. We said the function must be continuous. Got it. We said that the function value for the first x must not be the same as the function value for the second x. Furthermore, they must have opposite signs. Check, we got that. And because of that, we know that there is a 0 somewhere between f of 4 and f of 7. Well, that's it. By the intermediate value theorem, there does exist a root. Somewhere in here, that given function, there would be a constant. There would be a value of x where this function would be 0. So we're done.